So trigonometry is where we link the length of the sides to the angle, the angles in the triangle. As you can see here, if the angle theta was larger, then the opposite side of this triangle would also be larger. The way that I remember the trigonometric ratios is using the sentence, "Only hungry sharks attack healthy children on April Tuesdays." You might also remember it using the word Osakot, or there's another one that's like Sakatoa. But I prefer "Only hungry sharks attack healthy children on April Tuesdays." And I like to draw these triangles so that it's really clear what the ratios actually represent, what the ratios are. So the way these triangles work is whichever one of these variables is unknown, we cover that up. For example, looking for the opposite side, we cover up the O, and then that'll leave us with the hypotenuse times the sine of the angle. So the way these work is if we cover up the S for sine, we're left with opposite over hypotenuse. If we cover up the C for cos, we're left with adjacent over hypotenuse. And if we cover up the the T for tan, we're left with opposite over adjacent. So we can write out our equations like this. Sine theta is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse. And tan theta is equal opposite over adjacent. We can also use the inverse functions to find the angle. So if the sine of the angle is opposite over hypotenuse, then the angle will be the inverse sine of opposite over hypotenuse, or the inverse cos of adjacent over hypotenuse, or the inverse tan of opposite over adjacent. So I'll do a quick example to show you how we can use these trig ratios. Say for example we have a triangle that we know has an angle of 30 degrees. If we have a hypotenuse of angle 10 of length 10 units, and we're trying to find the length of this side here, first thing I'm going to do is label the sides of my triangle. H for hypotenuse. O is the side that's opposite the angle that we know, and A is the third side of the triangle. So in this case we're trying to find the opposite side, and we know the hypotenuse. So the ratio that we're going to use, we look for a ratio here where we have opposite and hypotenuse, and it's the sine ratio. So I'm going to write out and we're looking for the opposite side. So when we cover up O for opposite, that leaves us with hypotenuse times the sine. Hypotenuse and sine, they're on the same level. So that's going to be a multiply operation. So opposite equals hypotenuse times the sine of the angle, which in this case is equal to 10 sine of 30 degrees. So just pop that in our calculator, 10 times the sine of 30. It's important to make sure that your calculator is set to degrees. When we do that, we get a length of 5 units. And that's trigonometry.